Hello everyone, welcome back. Recent GATE papers have had very few direct mesh analysis questions, so let's look at an older GATE PYQ to see how the supermesh concept is actually applied. Let's first understand what is given in the circuit. We have a 5-volt voltage source on the left, two 5-ohm resistors on the top, a 1 ampere current source in the middle, a 10 ohm resistor on the right. We need to find the current I flowing downwards through the 10 ohm resistor. Now let's solve it step by step. Step 1. Assign mesh currents. First let's assign mesh currents to the two meshes. Let the left mesh current be I1 in the clockwise direction and the right mesh current be I2 also in clockwise direction. Step 2. Identify the supermesh. Now notice that 1 ampere current source lies on the common branch between the two meshes. Because the voltage across a current source is unknown, we cannot write KVL separately for the two meshes. So we combine the two meshes and form a supermesh. Step 3. Let's apply KVL around the outer boundary of the supermesh. Starting from the bottom left corner and moving clockwise, the 5-volt source gives a voltage rise of +5. The voltage drop across the left resistor is 5 into I1. On the right side, I2 flows through both 5 ohm and 10 ohm resistors. So the voltage drops are 5I2 and 10I2. Therefore, applying KVL, 5 minus 5I1 minus 5I2 minus 10I2 equal to 0, or 5I1 plus 15I2 equal to 5. Dividing throughout by 5, we get I1 plus 3I2 equal to 1. This is our first equation. Now, step 4, apply the current source constraint. Now we need a second equation, and this comes from the 1 ampere current source. Since both mesh currents are clockwise, I1 flows downwards through the common branch, I2 flows upward through the common branch. The current source is 1 ampere and is in the upward direction. Therefore, I2 minus I1 equal to 1. This is our second equation. Step 5. Solve the equations. Now we have the two equations with two unknowns. I1 plus 3I2 equal to 1. I2 minus I1 equal to 1. Adding both the equation, we get 4I2 equal to 2, which is nothing but I2 equal to 0.5 ampere. The required current I flows through the 10 ohm resistor. Since this resistor belongs only to the right mesh, its current is the same as I2. Therefore, I equal to 0.5 ampere. That's the answer to this particular question.